Good day, viewers at home. In our today's physics class, I will be teaching you how to find the resultant of more than two vectors whenever they act at a point. So whenever you have two vectors acting at a point, you are required to resolve either into horizontal component or vertical component, or even both. So let's assume that this represents our vertical component and this represents our horizontal component. So let here be Vx, x-axis, and here should be Vy. So here is representing our vertical component and here represent our horizontal component. From our previous class on parallelograms law, I can complete this to form a rectangle. Remember, a rectangle is also a parallelogram. So from that particular video, I also told you that the sides, the opposite side of a parallelogram are equal. So the opposite side of this particular shape now should be equal because it's a rectangle. So here will be Vy and here will be Vx. So here and here is equal. Then also that the resultant is the diagonal from the point of contact in my previous video. You can just go and revise that before watching this. So here becomes our resultant. Then there is an angle between the resultant vector and the vertical vector and the horizontal vector, or which is the component. So from here now, I'm having two triangles here. I have this and the other one, but I can take any of the triangle because they are equal. So here is theta, here is r, and here is Vx. As you can see here, Vx, and here should be also equal to this, which will be Vy. I believe that is clear. So once I have this now, what do? I can now use SOHCAHTOA to find the relationship between the angles and the sides of this particular triangle. So using sine, I'm going to have that sine theta is equal to opposite over hypotenuse. That is sine theta. And what is sine theta? Sine theta will be equal to, what is the opposite of this particular angle? The opposite of this angle is Vy divided by what is the hypotenuse, which is r. So that Vy will be equal to r sine theta. So if you want to resolve vector into vertical component, simply use sine theta. Then for the horizontal component, I'm going to have cos theta is equal to adjacent over hypotenuse. So that cos theta will be equal to, what is the adjacent of this angle? Is Vx divided by what is the hypotenuse? Still the resultant. So that Vx will be equal to r cos theta. So if you want to resolve vector into horizontal component, use cos theta, cos. And if you want to resolve vector into vertical component, use sine. That is simply how to do that. Let's take a few examples on that, on resolution of vector. So we have a question here. The question here says, calculate the net horizontal forces in the diagram below. The net horizontal, it is specified that it is net horizontal. So whenever you are faced with a question like this, what do? If you look at the question, this force, 4 Newton and 3 Newton, are already acting horizontal, but 12 and 8 Newton are not horizontal. Those that are not horizontal, resolve them into horizontal components, but this is already horizontal. So I have 12 Newton. 12 Newton will be 12 cos the angle because I'm resolving into horizontal component. So 12 cos 60 will be 6 Newton. And this is also not horizontal. So which will give me 8 cos 60 degree, which will be 4 Newton. So this 6 Newton and 4 Newton are now horizontal. So if I redraw the diagram, I am going to have, here I have 3 Newton. Here I'm going to have 6 Newton plus 4 Newton plus 4 Newton. Why am I adding? I am adding because they are moving in the same direction. And whenever vectors are moving in the same direction, I simply sum the vectors to get the resultant. So here I'm going to have 3 Newton is acting this direction, and a total of 6 plus 4 is 10 plus this is 14 is acting in the other direction. So that the total resultant now will be 14 minus 3. Why am I subtracting? Whenever two vectors are moving in opposite direction, I simply subtract. So I have resultant is equal to 14 minus 3 will be 11 Newton. That is how you find the resultant of vector. But sometimes in question or in exam, JAMB exam, they will not specify if you are resolving into vertical component or horizontal component. So if you are not specified that to resolve into vertical component or horizontal component, what you simply do is resolve all the vector into vertical component and also all the vector into horizontal component. I'm going to explain that. Okay, look at this question here. This question here says that the figure below shows forces 3 Newton, 10 Newton, 3 root 3 Newton, and 6 Newton acting on a particle P. The resultant of the forces is, so this question here, there is no specification if it is horizontal or vertical. So whenever you have question like this, the first thing you do is to resolve everything into horizontal component and also into vertical component. So how do I do this now? Solution. So I have vertical component and horizontal component. I'm going to resolve everything into vertical component and also into horizontal component. So if I'm resolving this into vertical component, remember this has divided itself into 4 quadrants. So this side is, this is your horizontal and this is the vertical. So this side of the quadrant is positive for the x-axis, which is the horizontal axis. Here is positive and here is negative, which you already know. Here is the y-axis, which is the vertical component. Here the upper side is positive and the one below is negative. And also in your trigonometry, here is 0 degree. The angle here is 0 degree because here from here to here is 90 degree, first quadrant. So here is 0 degree, here will be 90 degree, here will be 180 degree, here will be 270 degree. 0 degree, 90 degree, 180 degree, and 270 degree. But this particular, sorry, there's an angle here, 30 degree. So this particular 10 Newton, the angle of inclination is 30 degree. And the 6 Newton, the angle of inclination is 60 degree. So what will now be the angle of inclination of 3 root 3 Newton? The angle of inclination will now be 90 degree. And this will be 0 degree. Or you can use 360 degree. 0 degree. So what do I do now? If I want to resolve everything here into vertical component, let me start with 3 Newton. Let me start with this. This, if I want to resolve this into vertical component, I either take it to the positive direction or to the negative direction, but it will give me the 17. So I'm going to have 3 sine 0 degree. 3 sine 0, which is the angle. Because I told the angle here is 0. So 3 sine 0 will give me 0. So if I add or subtract, because if I take it to this side, it becomes minus. Because here is negative axis. If I take it to this side, it becomes plus. So whether I add or subtract 3 from a number, it will still be the same thing. So that is why this is 0 degree. Then I come to the next one, which is 10. So this, the angle of inclination of this one is 30 degrees. So 10 sine 30 degree. Why am I using, why did I use plus here? Because this will now be resolved to the positive direction because it is closer here than here. So which is 10 sine 30 will be equal to 5 Newton. I've resolved that. Then the next question I have here is the next angle I have here is 3 root 3 Newton. 3 root 3 Newton. What is 3 root 3 Newton? 3 root 3 Newton is something as 5.2. The 5.2 sine 90 will give me 5.2 because sine 90 is 1. So 3 root 3 sine 90 is equal to 5.2. Then the last is 6 Newton. the 6 Newton will not be resolved to the negative side because it is closer. So I'm going to have minus 6 sine 60 degree, which will be equal to minus 5.2. That is for the vertical component. So when I'm done with this now, I will not take the summation of the vertical component. This is minus 5.2 and this is minus 5.2. So this will cancel out this. So I have 5 Newton remaining here. This is summation of vertical component. Then I now take the summation of, I now take the horizontal component. So if I'm resolving this into horizontal axis, I'll start with the 3 also. This is, remember here is 0. So this will give me 3 cos, because it must go to the positive side. 3 cos 0. What is cos 0? Cos 0 is 1, so 3 cos 0 will now be 3. Then I take the 10 Newton. I resolve the 10 Newton also to this particular direction because it must go to the, it is easier to the positive side than to the negative side. So I'm going to have 10 cos 30. What is 10 cos 30? 10 cos 30 is 8.7. Then I have, this is 5.2. 5.2 cos 90 degree. And what is cos 90 degree? Cos 90 degree is 0. So 5.2 cos 0 will be 0. Then the last I have is here. So the 6 Newton will be resolved to this direction, not to this direction because it's closer here. So I'm going to have minus 6 cos 60. Minus 6 cos 60, which will be equal to minus 3. So when I'm done now, I take the summation of the horizontal component. This will cancel out this. What do I have remaining? 8.7 Newton. So this is summation of a horizontal component, and this is summation of vertical component, which means I'm going to have here is 8.7 and here is 5. Vertical component, horizontal component, so that the resultant will now be equal to, using Pythagoras theorem, I'm going to have 8.7 square plus, remember this is square, plus 5 square. So that arrow will be equal to, what is 8.7 square? 8.7 square will give us 75.69. Plus this square will give us 25. So if I add up this, we have 75.69 plus 25 will give us 100.69. So if I take the square root of 100.69, I have 10 approximately. So the answer to the question is 10 Newton approximately. Thank you for today's class. See you in my next video.